In the monsoon of 2005, when Mumbai was reeling under floods, BHN, a major offshore production platform in Mumbai Offshore, which belonged to the Indian major Oil and Natural Gas Corporation Limited, was destroyed in fire. Consequently, in order to restore India's energy security, ONGC decided to build a huge process platform complex called the MAHAN Process Platform and Living Quarters Project, consisting of one process platform with all the major facilities for oil, gas and water separation, one living quarters platform for 150 men, 3 process gas compressor modules integrated in M&P platform, 3 gas dehydration trains, 1 gas sweetening unit, 2 flare towers for flaring HP, LP and acid gas, all utility systems such as instrument air, nitrogen, diesel, etc. to meet the process, safety and operational requirements, 4 interconnecting bridges, associated modifications in the existing MNW platform. The overall project schedule was 33 months for the complete engineering, procurement, fabrication, transportation, installation, commissioning and handover. The project had to be completed on time without compromising on the strict safety requirements and operability criteria set by ONGC. Is it possible to meet customers' requirements and fulfill project timelines? Possible? 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 L&T took up the challenge in July 2009.
Is the project execution plan frozen?
No.
Are you serious?
Still, there are some engineering options we need to study.
It's impractical to execute the project in its completeness in a schedule of 33 months. It is impossible.
Yes, it's possible. First, you have to believe in yourself. When you believe in yourself, you will start planning. Planning brings in engineering strategy along with onboarding of your crack team. Strategy translates into action, action into results. Multi-locational approach, IT, collaboration and interface management. Innovation and creativity are the cornerstone of this world-class engineering.
The project milestone had 2 major requirements: jackets installation, 19 months, topsides completion and handover, 33 months. The first major part of the project requirement was the jackets design finalization. All the jackets had to be installed 12 months ahead of topsides. This required the topsides design, that is layout, weight, etc., to be finalized upfront. Only minor changes could be accommodated later. The main challenge of the project: extended feed verification and the detailed engineering of the MHN complex translated itself into multi-dimensional challenges for all the engineering disciplines. The layout engineering had to be finalized at the start of the project itself, keeping in view the changes that might come at a later date, whether it is safety study requirements or final vendor data. The other disciplines, mechanical, electrical and instrumentation engineering, had to monitor the vendor data all the time from day one, critically reviewing the changes that might arise due to their own engineering requirements as well as that of their vendors, to update the key documents like weight control report, which plays a significant role in jacket and layout design. The 2 important disciplines, the process engineering and HSE, had to finalize all the design data as well as the deliverables at the earliest. Process engineering was the first discipline to come online to define the technical requirements to other engineering groups involved in the project. This set the rhythm of the project. A multiple number of technical clarifications, around 5 volumes, had to be converted to design basis and other philosophy documents such as isolation philosophy, control philosophy, ESD and blowdown philosophy. The first and foremost activity was to freeze the feed requirements very quickly. Sizing calculations had to be completed. Electrical loads had to be frozen, including various scenarios such as black startup, restart and emergency loads. Package specs had to be defined. Material of construction had to be confirmed. All the philosophy documents, PFDs, P&I diagrams had to be finalized at the beginning itself, including vendor items. HSE documents such as hazardous area classification inputs, flare radiation and dispersion study reports, and all the safety studies workshops such as hazard, HAZOP, SIL, QRA, etc. had to be performed in time so that the outcome of those workshops did not alter the jacket and layout design adversely. No major changes were allowed as it would affect the layout and hence jacket's design. The layout team had to work hand in hand with process, mechanical, instrumentation and electrical teams to establish a layout configuration that was optimized to meet the jacket design. Layout should not change later but should meet the safety criteria as specified by international codes and standards and local regulations. The MHN project took shape in the mind's eye as the team worked in unison, building on its expertise, experience and commitment, setting benchmarks in teamwork and timely delivery while meeting the deadline set by ONGC. Normally, jackets are designed based on frozen inputs for topsides. However, in this project, engineering had to be done based on limited data. Precise and robust engineering calculations had to be performed so that only minor changes could be absorbed in the jacket design. The first major achievement for L&T-Valdel, that was a great feat. The next part of the project was to finalize the topsides design and installation requirements. The non-availability of the installation weather window and the unfavorable field layout of Mumbai High North with the added complexity of the pre-installed risers made the installation of topsides decks by float-over method impractical. Layout had to be carefully planned and finalized as the offshore installation of topsides decks called for a spliced concept, that is, module-wise installation of southwest, southeast, east, north and west, which would be placed on the jacket that was already installed. Interface engineering was one of the key factors in the design and essential for the successful implementation of the project. Communication failure could cause delays and errors, leading to the disruption of the project objectives. Piping team had to work very diligently, studying as many as 15 layout options to suit the jacket that was already installed, as well as meeting the installation sequence of topsides decks. Piping team worked along with other engineering disciplines such as instrumentation, electrical, mechanical, structural and process to freeze and finalize the layout design. The electrical lamps were never switched off in L&T-Valdel Engineering Ltd as the team worked round the clock. The various hands of the project working together achieved the great task.
We achieved a seamless integration of basic and detailed engineering activities by L&T's multi-centered engineering task force teams. Close coordination with numerous external agencies and vendors along with the OGSP PMD team, with a single objective to deliver and demonstrate the world the capability in executing such mammoth projects having multi-dimensional complexities with striking commitment to the project goals.
This prestigious platform, built by L&T, which was designed by L&T-Valdel, was dedicated to the nation in October 2012.
Today is a very special day for LTV. Our KB has formally handed over the MHN process complex, engineered by LTV and built by L&T, to ONGC.
The successful completion of the MHN project in time, while involving multifaceted challenges in a dynamic environment, L&T-Valdel set new benchmarks in engineering design and execution.